All right, it is time to start. It's a little before 2 o'clock, I think, but we have a full room here. So we will start talking about the web services protocol and architecture. My name is Omri. I manage a team called the Advanced Web Services team at Microsoft. Whoa! I have harassers in the front row. Our team is part of the Indigo business unit. Our team is responsible for the protocols and the architecture. And also a product we call Wizzy, which is a web services enhancements product that we have. This talk today is about the protocols that underlie Indigo and Wizzy and hopefully the rest of the industry as well. This is kind of a geeky talk. This is actually a geeky talk even by PDC standards. Oh my God, I get applause already. It's actually kind of bewildering to see how many people there are here at this talk, because there are only a few dozen people in the universe that will actually have to know the contents of this talk, hopefully. There you go. So the overall, the kind of the message you're supposed to get out of this talk after an hour of sitting here going through geeky protocols is, I'm glad I don't need to know anything else about this stuff, because Indigo does it for me. That's the moral of the story here. But because we're all geeks, amongst us geeks, we're going to go look at angle brackets. This talk has no code at all. Wow. I thought half the people were going to get up and leave. But it does have angle brackets. And so we will look at a lot of boring angle brackets today. Okay, I won't spend too much time setting up this talk. I'm kind of going to dive in pretty quickly. Because most of you went to Web Services, WSV 201, and got Don's philosophy talk. We like to call it in the speaker lounge Philosophy 201. I mean, that's the caption that we use. So I won't talk about services at all, except to say that it's an industry-wide phenomenon right now. It transcends web services. It's actually a methodology that we think is going to be as important in its time as the object-oriented methodology, and those two things are going to complement each other very well. Web services themselves are something that we believe are the kind of the final stack of the OSI model for the internet. I have a whole foofy picture slide on that, so I'll defer that to the next slide. But there are a bunch of trends going on in the industry today. Those are two trends. Another trend is IP is on an absolute tear in the device space, in a lot of different spaces. Places where we never thought that IP would ever shine its lovely face, IP is ending up implemented in. So my friend and associate John Shuchuk went to a conference called CEDIA, which is kind of the conference for all the consumer electronics installers that do custom jobs. It's kind of a harbinger for a lot of what's going on in the consumer electronics industry. And he said last year people were still doing stuff over RS-232. This year, pretty much every vendor out there has an IP stack in their device or has plans on going there, which is kind of pretty astonishing. IP is really reaching pretty much every niche of the distributed application spectrum today. And we think that web services is going to follow that. Today, those guys, the consumer electronics vendors, have a web server that gives you static HTTP pages, and you can type in, you can configure your device, and you can do very brute force kind of state changes, like turn on your stereo and turn off your stereo. We think that web services is a perfect application, or this, I should say, is a perfect application for web services. The mobile space is kind of as far away from that as you can go. The mobile operators have these big networks. They're all closed. They all have a lot of value, and I have a cell phone that I carry in my pocket. Most of you guys too. And there's a lot of inherent value that the operators are trying to get out of these things. First of all, they have a billing relationship set up with a customer. They want to kind of be able to charge more money and figure out how to get more services out. They know exactly where you are. They have a presence service built in. They have texting that they can send text messages to you. They can send video. My phone doesn't do video, but your phone might. And they have lots of stuff they really want to be able to open up to a bunch of different people to go program against. And just recently, we talked to Vodafone. We kind of did a press release with them. They were very excited about using web services to open up, to expose all the services they can do in their closed network to outside people to go program against. And they have already a billing relationship set up with a customer. So this is all a very good business model for them. So to make a long story short, we think a lot of roads are leading towards the service orientation, web services, and Indigo sits at the intersection of these trends. And that's why we're so excited about it. Really, web services is kind of the culmination of the OSI stack for the internet. Kind of the OSI stack. The only lingering effect that we've gotten or contribution to the field of distributed systems seems to be this reference model. The internet is actually what ended up winning there, but the reference model is very useful to kind of go analyze some of the protocol advancement in the space. IP, TCP were transformational phenomena for the connected device space, the distributed application space. HTTP gave us the web. XML and web services are going to go make the web programmable. So we think that web services is really the layer 7 of the internet, and that's effectively going to get us to the point where applications can go talk to other applications in an interoperable manner. So this is the web services architecture. The main point here is that we think of the web service architecture as kind of the rallying cry or the basis for a bunch of different connected applications. I've already mentioned devices. I've already mentioned mobile. P2P is a great application on top of web services. Grid is a great application on top of web services. EAI and B2B, already we know those are kind of the traditional uses that people kind of prescribe to web services. But these are all distributed systems today. They all have slightly different protocols. We think that they all will go to web services as kind of the unifying metaphor. And they're really going to help each other out in actually in realizing the value of web services. We're going to have every one of these applications add their additional value to the web services stack. And it's kind of a network effect. When you have all these things starting to talk web services becomes that much bigger. So we think that there's an inexorable trend towards web services becoming a fairly dominant phenomenon as an interoperable substrate for building distributed systems. So, because I talked for roughly 10 minutes already, I thought I'd start with a demo to kind of hammer home the whole point of interoperability. Interop is the #1 feature for Indigo in terms of things that you can't possibly cut. You can have, performance has to be good, but when push comes to shove, you're going to ship something that might go a little faster if you worked on it a little longer, but you're going to go ship it. And likewise with pretty much every aspect of the system, interoperability is one thing that just has to be in there for Indigo to be a truly transformational technology. We think that without interop, it's kind of a nice new evolution of ASMX and Complus and enterprise services and DCOM and all the things that we've been doing. With interoperability, it actually has transformational value because people are going to start using this technology and saying, I can tie in together a lot of heterogeneous systems that I have today. This really solves problems that I have today, or at least we hope that that's the value that people are going to see in that product, in that stack. So we did a demo with IBM on stage on September 17th. We actually had Bill Gates and Steve Mills, who's the IBM software chief, share a stage. It was the first time since, I don't know, 1975 or something, that two senior executives from these companies have actually shared a stage. I think it was after OS2. It was like 1992, I think that was the last time. And they were very well behaved towards each other. It was actually really nice. they, kind of completed each other's thoughts, and they kind of hugged, and, all we are saying is give soap a chance. They were very, very into it. But it was kind of embarrassing. No, but to be serious, this was actually kind of a watershed event for us, because the two executives got up and said, we are both betting big on web services. We are both betting big on interoperability. We're not necessarily the people who you'd think would work together because, we're competitors. And we make no claims otherwise. But we think it's very, very important for both of our businesses to succeed to go be interoperable. And that's a major statement to hear from an IBM executive and a Microsoft executive. Perhaps even more from a Microsoft executive. We finally got him. Anyway, so I'm going to show you this demo. Now, fear not. This slide, Don actually told me, you have to cut these foofy slides with clouds on them because nobody's going to take you seriously. And I was just too lazy to actually create my own slides setting up the scenario, so I just stole the ones that they showed the press and the analysts in New York on that fateful day on the 17th. So I don't even know how to talk to these things. The IBM actually put together these slides. They're beautiful. They probably got some people paid tens of thousands of dollars to put these great slides together, and I'm going to botch them. I'm so sorry. They're really good at that stuff. So we are, okay, I'm going to click through all this stuff. Okay, great. So we have a supply chain management scenario. We have a roaming employee of a supplier company named Tony. And by the way, Tony is a real person at IBM. They named all the names in the demo after real people at IBM. It was kind of interesting. Sorry. I don't know why I thought to talk about this tidbit, but it just popped into my head. Tony logs in to his authenticator, to his security domain, and what Tony does for a living is he sits at Starbucks, he sips his coffee, and he gets to log into the auto manufacturer because his company, the supplier, has an SLA, a service level agreement, with the auto manufacturer, guaranteeing that the auto manufacturer will always have the right number of parts in their system. Right? And this actually does happen in the automotive industry, where you have a bunch of suppliers that basically say, you, the auto manufacturer, will never run out of parts. So Tony gets to log in to the auto manufacturer's domain. Right? He gets to actually poke around there and see if the right inventory levels are there and the right orders are happening. And that's exactly what he's going to do in this morning as he's sipping his Starbucks coffee, on his Palm Top or whatever. And he's going to discover that these guys are low on parts. So he's going to place an order. But the connection is going to go down, poor Tony. But the fact that he's using reliable messaging will make everything work, which is great. So the X goes away magically. Secure, reliable connections. And then he's going to go talk to the ordering service running in the manufacturer is going to go talk to the warehouse service that's going to coordinate this very complex transaction across two different warehouses. I'm telling you, there were 20 project files for this demo. We had like 2 people that were working on this for 3 or 4 weeks straight to get this to work with IBM's stuff, and the fact that it worked at all was absolutely amazing because, in the past we just couldn't pull this kind of stuff together. But the fact that we did was a testament to the strength of the architecture, the fact that we can actually do interop with IBM software, and of course, our goal is to do the same kind of interop with BEA software and all the other platform vendors out there. So our goal by the time we ship Indigo, the reason why we can't ship Indigo in 2 weeks, as Don likes to say, is because we want to make sure that this interop thing is easy, and that when you install Indigo out of the box, it will be able to talk to all of these other platforms, including our own platforms that we shipped in the past, like ASMX v1 or Wizzy. So this is actually the less foofy kind of message flow scenario, right? So Tony, who is the guy roaming with his little tablet PC, is going to log into his domain here, the supplier domain, to his identity provider. And then he's going to get a token back from them. He's going to exchange that for the token that he needs to go talk to the manufacturing system, because the manufacturing system is in a different trust domain. And then he's going to go place a service through the manufacturing system, back through his own domain, the supplier, to a warehouse domain with lots of transactions happening, and it's all going to work, I think. I hope. Back. So now we're going to switch to this demo machine, and we hope it all works, because I didn't do my tech check last night. I forgot. And so we are going to pray to the demo gods that this actually works. This 25 project files solution that was supposed to show it, every single facet of the secure, reliable, transacted stack. Okay. I'm going to say an invocation to the demo gods. Don didn't last night. Dear demo gods, we hope that our demo here will work. Treat your humble servant well. And do not blow up this demo like you did to Don yesterday, because he did not say the same invocation. Amen. Amen. Thank you. Okay, now we will avert our eyes. Oh, actually, so I have this cute little product here from a company called MindReef. Cheap plug. Actually, I'm not associated with them at all. But it's basically a soap sniffer kind of thing, right? It listens on my NIC, and it just fishes soap messages out, and it logs them. And so I'm actually going to show you that this demo works. It's all on one machine. In New York, it was like on 8 machines, but we managed to kind of collapse all the tiers here. So I am Tony. I'm logging into my security domain. Blink! Avert the eyes. Is it going to crash? Is it going to crash? It says logging in. It says logging in. Please work. Oh my goodness, it worked. Claps are supposed to happen right now. Okay, all right. So we actually got a message here. And, okay. I don't like the pseudocode view. I like the XML view. There's the XML view. Lots of XML that we will actually look at a little bit later. I'm not sure that people can see this in the back row, and that's why I actually took the liberty to capture some of these messages and put them in IE so I could crank the font up, and we'll look at them later. But the basic idea is that I logged in to my system, and I got back a security token from my user ID and password credentials. Good? Good. I'm going to do my job, which is check the orders and inventory levels at the car maker. So now I have gone to the service in the car manufacturer domain, and I fired a bunch of application messages like view orders and view inventory and all sorts of stuff like that. And lo and behold, I have 15 of these Windshield Pro things, which I'm not quite sure what they are, but imagine there are some parts, windshield wipers. Let's call them windshield wipers. And there are only 15 of them, and I don't like that. I think that's pretty low. So I'm going to double click on this thing, and I'm going to try to place an order. And my order is going to be for 50 of these Windshield Pro items. And I'm going to, since I have a rich client that can actually pop toasts on my box here, I'm going to ask it to go pop a toast on Tony at Supplier. And I'm going to click OK here. And now the real fun happens. Lots and lots of messages start getting fired every which way. We got a purchase order message coming in. We got more purchase order messages. We got a ACK back. I think that's a reliable messaging ACK. We'll look at all these things. We got transactions happening, create coordination context, register, shipment order. Okay, good stuff happening. I don't know if this is going to complete or not. More RM ACKs back, create coordination contexts. As you can see, this is why it took a month to do this, because the IBM guy said, we want everything in this demo, secure, reliable, transacted. We want to show how much work we've gotten done. Rollback. Oh my goodness, something bad happened. The demo kind of has a life of its own. It just rolls back. It registers again because it's going back and creating more coordination context. It's oh my God, the toast. Order status notification received. Ah. Well, thank you. There's all sorts of stuff here. It's great. We're going to actually look at a very small number of messages that will exemplify some of the stuff that is in these protocols. Wow, now I'm 20 minutes in. So, without further ado, we will go back to the PowerPoint machine and start talking about the protocols. And as we go through the relevant protocols, maybe if I kind of remember, I'll go over and fire up the messages that we captured and go take a look at what those actually look like in practice. So PowerPoint gets to draw a little circle around these things. And before we do that, one more thing. We need to talk about the web service design principles. So these are actually kind of important. This is why we did what we did. This is a list of principles that led us down to the particular design path with the web services protocols. Number one, we wanted a general purpose framework that was composable, where we could actually add some of these protocols in as we go along, and you didn't have to have kind of an all or nothing thing. With DCOM, we had a DCOM v1 and a DCOM v2, and we could add some things in very discrete ways. But versioning was kind of difficult, and given the fact that we had XML as the substrate here, and XML makes versioning possible, perhaps not completely trivial, but possible, we decided that we would create a framework of protocols as opposed to just kind of a single monolithic thing. And it's really kind of helped us quite a bit, time and again, when we've actually added more complex kinds of capabilities to the system. So the flip side of that is that all these things have to work well with each other. They have to all be cut from a single piece of cloth. And we've learned a lot as we've kind of designed more of these extensions. Like, for example, the very first attachments mechanism that we did was SOAP with attachments. And then when we did WS Security, we realized, we need the same processing model, we need the same data model on top of these attachments that we do on top of the body of the SOAP message. Why? Because we want to use the same machinery to go sign and encrypt all those things, right? So we've learned a lot from this whole exercise, and it's kind of been a good validation of the entire architecture that we've been able to add more of these protocol bits without kind of totally jostling the whole system. Metadata-driven, policy-based architecture. The basic idea was that systems are dynamic, and you're not going to know everything, every possible thing about a system when you actually write the app, when you compile it. You might have deployment changes. You might have changes in transports. You might have different security requirements that get added. All these things are policy, are policy lifestyle choices kinds of things, right? I mean, for example, if I, as a service, only want to, only can support 56-bit DES encryption, and you, as a consumer, don't find that acceptable, you need a way to actually discover that. And that's not WSDL. WSDL tells me about the static operations that I can fire off against this service, and tells me exactly how I need to lay out my bits, my schema, to communicate with the service. But it doesn't tell me more metadata about the service that I actually really need in order to go communicate to it. That's what metadata-driven policy-based gives us. And this whole idea of negotiation, of figuring out what I'm talking to, what protocols you actually support, is kind of supported by that architectural principle. We have protocols that are factored from both the transports and the app semantics. We basically lifted all of the transport level goo and tried to put it in SOAP headers for the very simple reason that you might actually want to have a different message exchange pattern than what HTTP can give you. HTTP is request, response, request, response. And I might want to have a one-way message that I send, or I might want to have a correlated message pair where I send a message to somebody and asynchronously I get a message back at some point that's correlated through some kind of correlation mechanism, message ID. Or I might want to have a solicit response kind of pattern where I publish to a subscription source, to an event source, and I sync messages, and I might have lots that come, not just the reply, right? So pulling out factoring the actual protocols, the application level protocols, reliable messaging, transaction security, away from the transports is a good thing. And it actually enables the following point, which is having intermediaries. So HTTPS is a great protocol for doing secure communication between two web services. We like it. The only problem is if I have an intermediary in between, I need that intermediary to actually go decrypt the message, look at it in plaintext potentially, and then recreate another conversation with the final destination, right? So as an intermediary, I need to share two secrets. I need to share a secret with the originator, and I need to share a secret with the final destination. The nice thing about W security and the fact that the architecture allows intermediaries is that I can encrypt and I can sign portions of messages with the ultimate recipient's key. And so intermediaries don't have to know anything about the stuff that I believe ought to be confidential, which is great. So an intermediary, I'm a router, I'm an intermediary. I want to be able to route messages potentially to a cluster of machines. I can look at an addressing header, and I don't have to look at the body. The body can be encrypted, and I don't need to do that over HTTPS. So intermediary is a very important part of the architecture. Uniform data model across the protocols and the content. This actually gives us a lot of the kind of the routing scenarios that I was trying to allude to. I can write in a router, I can write a single expression over the header and over some stuff in the body, a single XPath expression that can help me route the message to the right place. So I can do data-dependent routing using SOAP. Where with DCOM, I mean, these things are completely separate, right? And Corba and all these other things. The body is completely opaque to me, and the protocols are just this goo thing that I can't actually even access. Here, I'm getting a message. I can look at the addressing headers, and then I could look at some of the body and do some intelligent choices based on those two things together. And finally, as I mentioned, I'm not going to belabor the point again, broad industry partnership, very, very important for us. Okay, time to stretch. Now, it's time to get into, about halfway into the talk, it's time to get into the protocols. So, every talk on SOAP starts, or every talk on web services starts with a very elementary discussion of SOAP, and I will spare you this very elementary discussion in this session. Because after all, this is a 400-level session. So we're just going to talk about addressing here. WS addressing. WS addressing is the workhorse behind our resource model in the web services protocols. It has two components. One of them is basically an enveloping mechanism. Kind of think about it as a generalized URI. Sorry, Gudge. That Gudge doesn't like that term. Think of it as a generalized URI that I can encapsulate a whole bunch of stuff about a destination, right? About an endpoint, about a service. And today I actually can do that with URIs, but I have to munch them up in very unnatural looking ways, and an endpoint reference is actually a very nice pattern for encapsulating all the information required to reach a particular service reference. So if you saw Don's talk on the 301 talk where he talked about service references, a service reference is nothing other than a reference to a service. And the endpoint reference in WS addressing is the wire level manifestation of a service reference. Right? The other thing that WS addressing gives me is rules for how to take the fields out of these endpoint references and just put them in the addressing header in a SOAP message. So just very canonical rules for how to take addresses and put them in a SOAP message. The most important part about WS addressing is that the internal organization of a resource is opaque to the caller. So here's a port at the very bottom. It has a logical name called a WSA address. This is a port just like an Indigo port, right? I mean, these are very synonymous terms. It's a WSDL port. It's a port. It effectively encapsulates an entire resource. And me, as the person talking to the port, only see that opaque resource. The resource itself might be organized in a lot of different ways. It might be organized in some encapsulated way, or might be organized in a kind of a scaled out kind of way, or no organization that makes sense to anybody, but it's up to the resource. And as the caller, I don't have to know anything about that organization. So this is exactly how I send messages through NATs, right? This is exactly how I send messages to a particular endpoint, and that endpoint from then on knows how to route it further. And the way we do that is we have these reference properties in the endpoint reference. The address is the thing that I actually take and eventually give to DNS and resolve to an IP address and go talk to over a particular transport. The reference properties are the things that once the message gets there, now that front, the thing that actually is listening on that port, can know how to dispatch that message. So this is what an endpoint reference looks like. It has, let's see, it has an address, it has reference properties, and it has potentially a policy. And I'm going to click through all these. By the way, I have 60 slides for this talk. There is no way I get through 60 slides in this talk. And so don't feel bad if we kind of skip over these things. The way I kind of put together the slides was put a lot of XML examples in these slides and potentially have these things be useful to you after the conference when you look at the proceedings. They're going to be on the PDC CD. But we're going to look at most of the angle bracket examples, hopefully, on the demo machine. So, very briefly, there's a set of rules that help me take things from an endpoint reference, the address and the reference properties, and just put them in the actual routing header in a message. Right? So the 2 comes from the WSA address. The reference properties all go into just the top level header of the SOAP envelope, and we'll show that in a second, or the SOAP header rather. And there are a bunch of different things that I can do in the top level header as well. For example, put the ultimate recipient, from, reply to, fall to, all these kind of endpoint references that I want to use in case I don't want to actually reply to the original from. Right? And then I have a message correlation mechanism called message ID. So I might actually give this message an ID, and then in a response message, have this ID get referenced to by this relates to field. So this is effectively how I correlate messages that are one way. So actually, let's switch over real quick. Let's see. I'm locked. 1, 2, 3. I had to bring this. So this machine was in New York, by the way. I did not want to touch it. Like, we had it in a vault at Microsoft somewhere. And we call it Big Bertha because it's huge. It's like 40 pounds. It's this enormous mobile workstation thing. So I don't know my way around it as well, and I apologize for that. Let's see. Any message will do, I think. Let's look at view orders. View orders. Okay. Here's the SOAP header. Let's crank the font. Font. Let's make the font big. Encoding. Text size. Largest. Big enough? Good. Excellent. So, SOAP header. The body is just a, kind of a little view orders kind of body. It says, hey, here's the date. Give me all the orders that correspond to that date. But let's look at the header. I have an action that's a WSA web service addressing header. This is a required field, and it has a from that has an address and no reference properties here, so this is a very simple message. I will actually show you at the very end a transaction message that does have reference properties and show you how we actually tie together those two transaction coordinators from IBM and from WebSphere and MTS, basically. I have a message ID. If I want to correlate to that, I can in my response. I have a to that is a endpoint reference. I have a timestamp that actually doesn't really relate to endpoint reference, but that's okay. That's what an endpoint reference looks like. It's a very simple thing, but it's a very powerful thing. It actually lifts the addressing destination from the transport and into the message. And again, that's a very, very important and central concept for us. Good. Make sense? All right. We'll skip over this thing. I basically show you how to correlate request and reply, and you already kind of know that through the message ID and relates to. Next up is metadata. Metadata has roughly 5 or so specs in that area. There's WSDL, which again, I will not show any slides on because this is a 404 talk. There's 3 policy specs, which we'll talk about, and then there's this thing, metadata exchange, that I'm not even sure I'm supposed to talk about, but we'll do it anyway. I am asked to repeat this talk. I guess there's a lot of people waiting outside or something? Okay. Oh my goodness. 8:30 a.m.? You just killed my partying night tonight, man. I swear. Okay. I will reply later. You can't hold me to it right in the middle of my talk, man. Okay, all right, we're just going to ignore the person in the blue over there. Policy. Fine. I aim to please. Okay, I took one for the team. Okay, policy. Policy has 3 specs. There is WS policy, which is a framework for making statements about resources. We already talked about that metadata-driven architecture. That's exactly the framework that we're talking about, and we'll talk about that in detail. There's a policy assertions, which is just a couple of canned assertions that we think are useful. Policy attachment is a way to attach policy to a domain, to a subject, like an endpoint reference. So this is a very beautiful build slide. All of these slides, by the way, none of them are mine. They're all due to these wonderful people that are sitting over there and just talking to each other and don't even know that I'm talking about them. They absolutely have no idea. Absolutely no idea whatsoever. They're just still conversing there. They write beautiful slides. By the way, this talk is a condensed version of about, I don't know, a few hours worth of material that these folks have kindly all recorded using Presenter and are going to be on your PDC CD. So the good news is that I don't have to go through all my material because it's all there. Metadata-driven architecture. This is a beautiful Jeff slide. Here's how it works. Service X wants to talk to Service Y. Now, there's no caller and callee and service and client and server here. They're just peer services. That's the world we live in. The world we live in is asynchronous, and services just want to talk to other services. Service X says, I want to get your policy, Service Y. Service Y gives them the Service X back its policy. Now, this is very important. Service X will actually do the intersection on the policy locally. It'll say, that's what that service supports. Now I'm going to look at my requirements and see if that service meets my requirements. For example, do they use strong enough encryption? They do. Okay, I'm going to go talk to them. So I'm going to send a message, and effectively, the message that I send will have to meet the peer's requirements, right? Because I know that if I send you a message with 56-bit encryption DES and you take nothing less than 128-bit keys, then I won't actually work. But it's really up to the caller to make those decisions. So WS policy is a way to express these kinds of preferences, these kinds of requirements in a language. And it's the kind of typical language that you would really think you'd have here. You basically have a bunch of Boolean compositors, operators we call them. Exactly one is one of them. That's an XOR. All is an and there's one or more, which is an OR, right? And so here, these are due to Jeff again. Jeff likes his lunch, and he will either eat only a burger and fries or pizza and yogurt, right? No other combinations will work for Jeff. Jeff is very picky. That's the way he is. And in fact, these are the domain-specific assertions that I'm actually doing my policy over. Here's a preference. Jeff actually likes pizza and yogurt better than the burger and fries. But in actuality, it's really only a hint to the requester. The requester is going to look at these things, and if they only can give Jeff pizza and yogurt, then that's what they're going to do, regardless of what his preferences are. But in case the requester actually supports a broad range of things, and the requestee supports a wide range of things, there might be some optimization that can happen there. For example, if I support 2 encodings, a text and a binary, and the requester also supports those 2 encodings, I might actually want the binary to go proceed first, right? Make sense? Okay, policy assertions. Policy assertions, they're kind of 4 somewhat useful policy assertions that we've created. Sorry, there is a question. Oh my goodness, that's a hard question. So, you can do this at design time, you can do this in runtime. Question is this design time or runtime? The line between design time and runtime is kind of blurry. The service will never work if it changes its policy after you've actually done some genning, right, at design time. So the check happens at runtime, but I can do some design time help with a tool to actually make sure that these things actually go talk to each other. I don't have to do that at runtime. So actually kind of the interesting one here is spec version. This is a mechanism whereby which I can actually version these protocol headers. Right? I, as a service, speak this 2002/04/whatever version of the W security spec. That's actually the very first W security spec that we shipped. There have been others since, like for example, Oasis has shipped a different W security spec, which is actually really nice. We like it. And so, but this service only supports that initial one, and that's kind of how I do my versioning, right? There's another message predicate. We'll actually skip over that one. Policy attachment, very simple. It's a way to attach policy to a domain expression. Typically an endpoint reference, but it could be a WSDL construct like a service or a port. It can be anything. It's just the way I attach policy to a thing. Go ahead.
Do you have a mechanism for versioning policy if you're superseding policies with new ones?
Do I have a mechanism for versioning policies? That's a good question. I think that's actually kind of an app question. So Indigo might have a mechanism for versioning policies. Okay, so moving on pretty quickly, metadata exchange. So this is a spec we haven't shipped yet, and that's why I kind of feel a little weird talking about it. But it's so close to being shipped that maybe I should, and we've done lots of forward references to that spec. So how do I actually get metadata for another endpoint? I could get it from WSDL, or I could get it by you giving me a diskette with it, or I could actually get it out of a UDDI source or any other directory, or I could actually create a convention whereby which a service supports just a well-known action, a well-known WSDL operation, like a get policy or a get WSDL or a get schema, right? And that's how you get policy back. So this is just kind of a simple thing. Well, the angle brackets don't mean really anything here. This is just kind of how conceptually we think about it. And hopefully we'll get that spec out pretty soon. Okay, security. Another stretch. How long do we have? I am 40 minutes into my talk. Okay, I think we're okay. So we have 5 specs that we've shipped so far in this category. There's security, secure conversation, trust, security policy, and federation. I will not talk about federation. That will add another hour to this talk. Federation is an interesting application on top of these things that talks about how, in practice, you federate identity management systems. It's a very interesting spec. I encourage you to read it. It's actually a very interesting spec for understanding what trust is. So it's not that it's not important. That's not why I'm not talking about it here, just for the sake of time. W security gives me 3 things. It gives me ways to do integrity, confidentiality, and propagation of security tokens in SOAP. It supports intermediaries. We talked about why that's important. And it's very pluggable in terms of algorithms. Keys, encryption algorithms, digest algorithms, signatures, canonicalizations, transforms. It's slices and dices. It's all good. So here's an integrity example. I want to send a SOAP message and ensure that the body's not modified. Right? This is an integrity kind of scenario. So what do? I generate a digest on the SOAP body. A digest is a cryptographical message hash. I generate a signature over the digest, because signing a big message is slower than signing a digest. And I include the certificate with which I sign the message with that message. So, build, I hate builds. Build slides. Okay, this is what the message is going to look like. I'm going to take the message body, the digest algorithm, the digest, the signature algorithm, the certificate, all packaged up in a security header. That's why they get big. As a receiver, here's what I do. I want to check that the body of the message was not modified. So I do the reverse, the inverse process. I take the message body, run it through, run it through the digest algorithm, get a digest. Now I take the signature, run it through a verification algorithm, get a digest, match these up, make sure they're the same, and voila, I have message integrity verified. And as a side product, actually get to know the identity, confirmed or unconfirmed, based on the trust model that I have with the sender of that message. So let's switch over and let's look at the WS security header. And this is going to be very interesting. It's going to be telling how good I am.
You guys are delivering products that don't work unless you run as administrator all the time. And you're doing it because you guys are running as administrator all the time. You guys have got to start eating your own dog food.
I am very sorry. I humbly take your feedback, and I'm just not going to do this demo anymore. I just feel so embarrassed and ashamed. I'm sorry. No, I don't mean to belittle that at all. I agree with you. It so happened that I had very little time on the plane to prepare for this, and I had to, go do unnatural acts. But I agree. Point well taken. Okay, so let us look at a good security thing. Which one? Let's do this one. This one is, I have lost the audience after being so embarrassed about that. I'm serious. No, I'm not laughing. I understand how important this is to actually give our customers the right, the right model. Okay, all right. So here is a purchase order that I am sending from the manufacturer through the supplier to all the warehouses. It has a bunch of stuff in there. I don't really care about what the purchase order looks like. All I care about is the headers. Okay? So let's look at the headers. The header has an RM. I'm not going to look at that. That's not until later. Reply to a bunch of stuff we've already seen, this timestamp thing. Okay, here's the security. Here's the security header. Very interesting security header. Okay, I have two things here. I have a binary security token. It is an X509v3 token. It has an encoding type and all sorts of stuff like that. We will see what it is used for exactly. The signature is basically the signature I compute over the message. Now, it has a whole bunch of references here. And I'm going to make all these small. And I'm sorry I'm not faster with this, but this laptop, Big Bertha, has a weird kind of mouse kind of thing. Okay, each one of these references has a URI reference to a part of this message. So every one of these other headers has an ID. Let's look at the from. From starts with ID-B6FE. Can I find it? Yes, I can. It's this guy right here. So everything I want to assign, I create a reference tag for. The reference tag has what transform I'm going to perform over that. That is, what canonicalization algorithm I'm going to use in order to canonicalize this stuff. It has a digest method, what technology I'm going to use to actually compute the digest, and that is SHA-1 here. The canonicalization algorithm is XML exclusive canonicalization. These are all W3C recommendations. And at the very end here, I have a signature value that I compute over all these references. Then finally, I have the reference to the security token that I use to actually do the signing. And that says DF141. Let's go up. And that is none other than this original binary security token right here, DF141, whatever it is. Right? We use kind of GUIDs for this, this whole sample. Sorry about not using more descriptive names. But it is the Gates Mills demo, and I didn't want to touch it. That's, in effect, how you do message integrity.
Where are you validating that the certificate that signed all this thing is valid?
That is a trust thing. So I have a trust relationship with somebody, right? And I can basically I have to have a trust relationship with an authenticator, right? For example, when I log in to a Kerberos realm, I trust that Kerberos service out there inherently, right? And I'm getting back a certificate. Now, somebody else might trust my user ID and password credentials that I pass, or somebody else might trust that certificate because it was signed by a different certificate authority, if it was an X509 token, that kind of thing, right? Trust has to be established out of band. And that's exactly a great segue. Blah, blah, da, 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 da. Skip all over all the angle brackets. That's a great segue into trust. WS Trust defines how to broker trust relationships. The trust relationship has to exist a priori. That's a very important point. I can't actually, through any kind of computational mechanism, devise a way that you trust me and we don't know each other at all. Right? We have to have some way to broker those things. There could be direct trust, like you and me just know each other, and we kind of walked over and we exchanged driver's licenses, and I feel pretty satisfied that you are who you are. There is indirect trust, where we both trust a third party, and they do the brokering for us. WS Trust basically codifies how you exchange tokens based on trust relationships. It has two messages. It defines just two: an RST, a request security token, and an RSTR, which is the response. The model is very simple. I want to talk to resource X. I talk to a trust service that both of us trust. It gives me a ticket to go talk to resource X. And then I give resource X the token that it actually expects. So, away from PowerPoint, back to, I hope, am I ever, oh, okay, fine. Good. Should we use the same one? No, we can't. We have to use a different sample. Okay. Here is the very first message that the client, that the app, the Tony app, sent the IP, the identity provider. So, let's collapse all these headers. The from, the timestamp. We want to look at security. Actually, let's not look at security yet. Let's look at the body first. The way RST is sent is in the body. Here's request security token. It asks for a SAML assertion token because that's what the other side, the car manufacturer, actually wants to see. Right? It doesn't understand my X509 certificates. It doesn't understand my user ID password. All it understands is a SAML token. Great. So I'm requesting a SAML token from my identity provider. Nice. I have two. I basically base my request on this security token over here that I sent in the security header, which I'll show in a second. And then there's this reference that I'll talk to in just a second when we talk about secure conversation. But let's look at what this reference is. It starts with a DECB. Dog, Echo, Charlie, Bravo. Where are we? Oh, here we go. It's not this guy right here. It's not this guy right here. It is a username token. There it is. DECB7FEC. So I'm basically giving my username token to the authenticator, and I'm getting back a SAML token back. And that's how I go talk to that other service right there. Should I show? Yeah, I should probably show the RSTR also. So actually, it doesn't add a whole lot to the demo, but just to show you what the reply looks like. Here's the header. Here's the body. Here's the request security token response. Here's the requested security token. And I have some SAML stuff here, a bunch of SAML stuff that we don't have to really look through. And I have the proof token that actually proves that this thing is valid. So, back to back to my PowerPoint. Let's go back to the XML here, and let's see. Yes. The example that I showed of the very first token exchange that happened there wasn't complete. I kind of glossed over one thing. I glossed over, let's see, request security token. I glossed over this supporting thing right here. I basically have two keys that I'm effectively using to establish this, to get that trust. right, to get that that security token back, the SAML token. Now, what is that other token there? It is a security context token. I have established with that identity provider a previous relationship. I am referring to that previous relationship. There is an identifier to this thing right here, WSU identifier. There is expiration timestamp, things like that. And I have some key information here. This is perhaps how, within that security context, I'm talking about which key I want to use. It's an X509 key I happen to share with my identity provider. Now, why is this all important, you ask? Well, that's because I glossed on another thing in here, which is the username token. If you look at, I'm going to try to close some of these things because it's a little confusing. There's so many angle brackets. Here's the username token. If you actually look carefully, there's no username information here at all. It's all encrypted. Why? Because I don't want to send any of that information in the clear. Right? So what I effectively do is I use that previously negotiated security context token. I encrypt with that my user ID information so I don't transmit in the clear. And that's why I effectively have two of these things. One is my user ID, my username token field, that's the base, that's the reference. And then supporting credentials are that SCT that I share with the identity provider. Okay? So that's one usage of secure conversation. I had a context that I already created with that X509 identity provider, and we've already agreed on it, and now I can send my user ID password and in an encrypted kind of way. Okay, security policy. How are we on time? About an hour into it. Okay, security policy is a set of policy assertions. We already know what policy is that relate directly to the security specs. So, things that are examples of security assertions. One example is, I want to tell you what token types I support. I support X509 tokens, right here, or I support Kerberos V5 ticket granting tickets as a service. And you know, my preference for one is actually higher than the others. The numbers are actually just integer compares, so the 100 means nothing here. But this is a way that I tell you that I support exactly one of those things. I don't want to see both. I just want to see one of these things, but I support both of them. Integrity is another security assertion example. So here I actually say, here are the algorithms I support for integrity. I support this algorithm for canonicalization, this exclusive canonicalization from the W3C. I support the RSA SHA-1 digital signature algorithm. I support the HMAC SHA-1 digest algorithm. That's effectively how I make security policy assertions. All good? Okay. Reliable messaging. The fourth out of 5 topics. So I might be on time, amazingly enough. Before we delve into reliable messaging, we will talk a little bit about how we think of reliable messaging versus atomic transactions versus business activity. It turns out that all three of these technologies can be used to coordinate distributed state changes between multiple parties. And we had different requirements, different scenarios that led to the evolution of 3 different things. Reliable messaging is a 2-party protocol. It has a source, it has a destination, it's asynchronous in nature. I send you a message. At some point in the future, you will send me an acknowledgement. I will not free up my resources until you give me that acknowledgement, because I don't know that you got that message yet. I might retransmit it periodically. So that's reliable messaging, very similar to any type of message queuing technologies that we know and love today. Atomic transaction and business activity. Actually, I'll skip talking about the differences here. I'll actually address them when we get to those sections in the presentation. Reliable messaging is very simply the definition of quality of service over a unidirectional message sequence. If I want quality of service exactly once in order over both directions, I need to define 2 correlated reliable messaging sequences. The basic idea here is that it simplifies application programming. I don't have to defend against things like lost, duplicated messages. I don't have to defend against networks going down, router storms, any of those things, typically, right? I really have to, I can now think about my application logic. I can do fire and forget. Acknowledgements are sent upon receipt of the message by the networking infrastructure, by the actual, by the platform. That is, Indigo gets a message and sends an acknowledgement. It's not that the application process does anything and then the acknowledgement is set. So this is really a system level as opposed to an application level reliability protocol. And durability is actually not defined in the spec, which is kind of amazing but true. It turns out that you can do volatile reliable messaging or durable reliable messaging depending on the scenario, but the protocol looks exactly the same. Now, if I am doing some business with you, I will want to know that you support, putting the messages in queues and things. So I pretty much have to have a policy assertion for that. But I can use the same protocol if I'm talking to something on, cross-process or something like that, where it might be that the process dies, but I actually don't need that durability requirement. I want to go fast. So, sequence example. Let's go back to the angle brackets. Sorry about my voice, by the way. I kind of lost it singing songs with Don, and all we are saying is give soap a chance. Let's see. PO.xml. Perfect example. This is the kitchen sink of my messages here. Let's kill all the rest. Actually, we don't even need to. Here is a WSRM sequence header. It has an identifier. The identifier has a unique ID, some URN. This one is a UUID. And it has a message number. This is message number 1. The message numbers have to be monotonically increasing. The identifier has to be unique across space and time. I can send message 2 after I send this message 1. And I can send message 3 after I send message 2. And I am guaranteed, I know that if my peer actually is a good, reliable messaging endpoint, it will deliver message 1 before message 2 and message 2 before message 3. And it will deliver each one of them exactly once. So if I'm a good client, the way I have to support this protocol is I have to save every one of those messages that I send in some kind of queue, durable queue perhaps, until I get a sequence acknowledgement back from my peer saying that they actually got the message. If I am a receiver, I have a tougher job. Because if I really do want to give exactly once in order, and exactly once is kind of the hard one here, I have to save all the messages that I got up until some point in time where my timeout expires, and I really want to express that in policy, right? I want to say, I keep messages for a day. Or I get this last message. If I keep on getting messages and I get this last message, I have some other timeout that I have to wait until before I throw all these messages away. But as a receiver, I have to save a lot of messages in order to be correct on this protocol. Last message basically tells me that this is the last message of the conversation. It helps me, kind of gives me a hint in terms of resource cleanup. So here's my ACK. My sequence acknowledgement has the same identifier, and I didn't remember to point that out, but trust me, it has the same identifier. It has an acknowledgement range of upper 1 and lower 1. That is, I'm acknowledging exactly one message. I can acknowledge multiple messages using the same sequence acknowledgement header. Now, this is not a super interesting reliable messaging kind of example, but it's a real one. It turns out that the body is empty, and I just effectively sent this PO, this purchase order, from the manufacturer to the supplier that had all these quantities in a reliable kind of way. And this really did work. We actually had the folks on stage feign some kind of network outage and re-plug in things, and everything seemed to work fine. So that's reliable messaging. Back to PowerPoint. The final thing I want to talk to you about before we actually talk a little bit about the process of these specs, is transactions. Atomic transactions, the typical thing. You probably heard Jim Johnson Don talk about the transaction support in Indigo. This is the protocol underlying it. It's a classic ACID two-phase commit protocol where you have two phases, prepare and commit a rollback. It can be either volatile or durable, and I think Don talked about that a little bit. I'm not going to get into the actual essence of atomic transactions here. The important thing is that it is, in application semantics, a synchronous protocol, because every one of my participants in my transaction has to be up in order for the transaction to go forward. If one of them is not up, I have to roll back the entire transaction and then try it again. So atomic transaction is kind of trigger happy on the abort side of the commit abort. If anything goes wrong, the transaction aborts. So it's a very appropriate model where you have low latency and high degrees of trust between systems. It's a model that's worked very, very, very well for the last 20 or so years, 25 years since Jim Gray wrote his papers, and IBM built it, and we built it, and BA built it. It's a great inside the firewall kind of solution. It is not a solution across the internet. It is not a solution across the internet where my assumptions cannot be that coupled to each other. It also, it's important to note that this particular protocol uses asynchronous messages underneath the covers. So while it is asynchronous in terms of application semantics protocol, I can actually have multiple transactions that are occurring, and I don't have to wait until the commit or the rollback get sent to me from the commit coordinator. I don't have to keep a socket open. I don't have to tie a thread on the receive call. So I have some inherent nice features of scalable systems where I can reuse my thread pool, which is great. So that is a very nice improvement in the model. The programming model is very easy. My resources are locked. This is the beauty of transactions. So I have a very easy programming model. It either didn't happen yet or it happened. But the flip side is that the resources are locked. So again, it's not appropriate for internet scenarios. I'm not going to spend time at all on the AT abstract state diagram. It's a phase 1 and a phase 2. I think that's for a different talk. Business activity, by contrast, is a different kind of model. It has a looser isolation model. I can see intermediate states. It's kind of almost like a chaos model for atomic transactions. But the important thing is operations aren't undone. You move forward to a known good state as opposed to back to a known good state. The idea is that the state, the shared state, settles out at the end of the interaction. So I can do a couple of things. For example, the typical tried example that we use is I am flying to PDC. I want to give a talk. I am making a plane reservation. I am making a hotel reservation. I'm making a car reservation. In an atomic transaction system, all succeed or all fail. For me, I actually really, really do want to be in LA to give this talk, even if I don't get a car. I mean, I could get Jeff to drive me around. He was very nice in offering a ride from the airport, if he's so kind to do that again. So, point is, I don't want atomic transaction for this scenario. I don't want an all succeed or all fail. I want to have options. I want to be able to try plan B, perhaps. Plan B is rely on Jeff. I may use compensation. In the case that I didn't get my hotel room, I'm not going to sleep on the street in LA. I don't like LA that much. And sorry, I love LA, just not that much. And I might want to actually do a compensation. I might want to cancel my reservation that's already been issued with the plane reservation system, right? That's how real systems work today. When I make my plane reservation, that seat is gone. And then when I cancel it, that seat comes back. I don't keep an ACID transaction open for the duration, right? So I relax my complete agreement requirement, which gives me some options. But the hard thing is it makes my programming a little bit harder. I have to adjust to a much broader range of application scenarios. I don't have requirement to lock resources, but again, the minus is I see a lot of intermediate states. So this is really appropriate for scenarios where you have to cross trust domains, like internet scenarios. Coordination, last but not least. By the way, I'm sorry, I should have said this. Every single protocol you've seen in this talk today is implemented in Indigo, I believe in the M4 bits, certainly in the M5 bits, with the exception of WS Business Activity. That's the only one that's not in there. We love WS Business Activity. We think it's a great scenario. We just didn't have time to put it in. WS Coordination is the base protocol for AT and BA. We kind of took all the plumbing that is used to create coordination contexts and to do to register for a transaction and just put it in a central place. Based on WS addressing, and it has the 2 coordination types today, but it is extensible to more. So I'm actually going to, in the interest of time, just show you on the slides what the WS atomic transaction register example looks like. And this is kind of how we tie back to addressing and those reference properties. This is how IBM and us got the transaction systems to work together on stage. So important. I am sending, as a transaction manager, a register to another transaction manager. I am getting back in my register response a endpoint reference. This coordinator protocol service is of type EPR. It has an address. It has reference properties. I have a transaction ID and an enlistment ID. Now notice the namespaces for this are these MSTX things. That's a Microsoft namespace. That's okay. The IBM transaction monitor does not need to know anything about what these things are. All they know is to put those back in the messages that they send back to me. Right? So I get register response. Now, when I, as the preparer, want to tell that other transaction manager over there, I'm preparing a transaction, I need to send to that WSA address here, the 2. Here's the action, prepare. And I'm just going to sprinkle in those reference properties, transaction ID and enlistment ID. And then that other transaction manager, be it DTC or whatever, knows exactly what to do with it. The internal organization is completely opaque to the overall coordinator. But the other coordinator, the DTC system, knows exactly what to do with those things. And it was actually amazing how quickly we managed to get these 2 transaction monitors to work. It was astonishing, right? I mean, here are, obviously, our transaction monitor, MTS, ComPlus, what have you, enterprise services, can go talk to a lot of resource managers. They can go talk to Oracle. It can go talk to SQL Server, a bunch of different things. But here is a different transaction monitor, a WebSphere. And these things are actually coordinating transactions across between them. And that's a really big deal. And we did it in less than a week trying to set this demo up just by following this pattern, this very important pattern, the resources are opaque. And we just, I mean, it really kind of gave us a really nice validation. We felt really good about the architecture at that point in time where we actually really got it to work on stage. So this pattern, the atomic transaction pattern, very important pattern for building enterprise systems, can be built on top of the web services architecture in a successful and interoperable way. Wow. Smattering of applause. Thank you very much. So, last but not least, I want to talk about the spec development process, and then I'll give you a few resources. I'll be available for questions a little bit after this at the web services speaker lounge. Here's how we think about specs. This is the only process slide we have here. Microsoft and partners, we basically take the industry leaders. Sometimes we're one of them. So IBM is one. BA is typically one. RSA for security, VeriSign for security, SAP for policy, TIBCO for reliable messaging. We take all those folks that have significant interests in the market and thereby have a lot of experience in that particular domain, And we go write specs together. And we publish them. And then we enter what's called the workshop process. The workshop process is where we get lots of feedback from the community at large about these specs. And we take them and do interop fests, interop workshops. And we learn lots and lots about implementing these things and trying to do interoperation between those implementations. And that feedback loop makes the specs really good. When the specs are good, we submit them to a standards body, W3C, OASIS, what have you. The job of those folks is to make it so, make it good. But the important thing is we've given them a good spec, a good interoperable spec. And that shortens the cycle, the standardization cycle that can sometimes be long, considerably. We've had great success with this. So with XML schema, we gave the W3C a note. It wasn't very well implemented at all. We kind of implemented it in our product. Nobody else did. It took the W3C roughly 3 years to get XML schemas, but it really was designed by committee, and it leaves some folks, at least in the community, somewhat feeling empty, feeling like they need something else. So here comes James Clark, very smart guy. I love James Clark, and creates RelaxNG. And RelaxNG fits some of the bill, and we go, it's kind of nice for those scenarios. We actually decided that with SOAP and with some of these WS specs, we would actually go try to create something good with the big partners out there. And then, once we had something good, give it to the standards bodies, and then they would have a much better time, much easier time coming up with something good. So W Security, we took through this workshop process. We published it in April of 2002. By September of 2002, we actually submitted it to the OASIS Security TC. Less than a year later, we already had a spec that has a stable URL that we can point to and say, this is a standard. It took less than a year, which is just, by standards measures, it is fast. Trust me, it is fast. If you don't know it, it is fast yourself. So the other nice thing about it is that we actually got lots of implementation and interoperability experience. We take these, the input that we get in interop workshops, and we create profiles out of them. And organizations like the WSI or the UPnP Forum for devices basically are in charge of creating profiles out of these specs. Profiles basically limit the universe of choices that is unbounded with some of these specs. When you say W security is completely pluggable, okay, that gives you lots and lots and lots of options. How do I actually encode certain token types? How do I encode an X509? How do I encode a Kerberos ticket in an interoperable way? How do I encode a SAML thing? That's the role of the profile. The profile says, here's the underlying subset of all the solution space that is going to be interoperable. So this is our process. We think it's worked really well for security. We're starting to push all the rest of the specs through it. Reliable messaging has had a interop workshop back in October, wildly successful. 7 implementations were brought. They all interoperated on the scenario. We're going to do more interop workshops. We agreed that we need more for reliable messaging. But that's exactly how the process, we feel like, is going to kind of play itself out. And at the end, we will have great interoperability across all the vendors. It's not enough to actually have a standards body bless a spec. It's important to have all the rest of the folks actually go implement them. And that's why we say, that's why we can be serious when we say interop will be an out-of-the-box feature of Indigo, because all the partners feel exactly the same way. So that's more or less the end of the talk. My call to action is, I've already mentioned the PDC CD has talks from these fine gentlemen over here. We have the web services spoke that is a great source of information on all these specs. All of them are online. They're organized kind of nicely. We try to improve the organization. Early adopters, if you need to do something today and you don't have that in the ASMX stack, it's kind of what we call an advanced feature. It is security or it is a reliable messaging when we get it. Use WYSI. WYSI has a very important to understand contract with you. It is an early adopter technology. It is fully supported by our product support. Fully. But only for 2 years. And 1 extra year of extended, I don't know what they call it, support. The express purpose is that WYSI is like a fast-moving kind of thing, and that your contract is you get to rewrite your code to the next version of WYSI. Your contract is you get to rewrite your code to Indigo. We will make the last version of WYSI wire format compatible with Indigo to ease migration. But the point is that this is early adopter technology. If you believe that you can get first mover advantage in your area by using some of these advanced functionalities, WYSI is the right way to go. If you believe that, you know, this web services thing, it might be big someday, and I'm going to wait for it to get big, and I'm going to, you know, really kind of wait until it's supported in a 5+2 platform, wait for Indigo. The beta is in the summer. Finally, attend workshops. Workshops are open to the public. Come one, come all, everybody's welcome. Anybody who has thoughts about these specs can give us feedback on them. The interop events are really kind of for people who have implementations. You can show up. If you don't have an implementation, you might get bored. But it's a very open process. We try to make it as open as we possibly can. We want your feedback. Please give it to us. That's about it. That's the end of my talk.